Um, Hi everyone. I'll talk about our paper Improving Multi-Op Reasoning in LLMs by Learning from Rich Human Feedback. This was work done as an intern at Amazon. So as we have seen in last few years, large language models can do pretty well at reasoning tasks, but they do especially well on simpler reasoning tasks. So these are like graphs for as you have larger models, and the first one is like relatively simpler task. But models are still not perfect and they're still lagging for harder reasoning tasks. So for example, the second graph is on a task which requires multi-hop reasoning with implicit strategies. Nevertheless, models are not useless at these harder tasks. They can provide partially correct answers. So maybe some steps in their reasoning are correct, but some of them are wrong. And that motivates our main research question, which is, can we improve multi-hop reasoning by learning from feedback on these model-generated answers, which are partially correct? And our pipeline would look something like this. So we'll initially prompt the model with with a question, the hard question. We'll have a reasoning chain generated by the model, which might have errors in some of the steps. We'll show it to humans and we'll collect some kind of feedback on this reasoning chains, and we'll use that to update the model. So we do it for data collection using two seed data sets. So we use strategy QA, which I just talked about before, and we also use another data set from Big Bench, which is also multi-hop reasoning, but in a narrower domain of sports understanding. And for this model in the loop data collection, we used either GPTJ model or FLAN-T5 model to do data collection. So here's an example of the kind of feedback that we collected. So initially we have the question, which we prompt the model with along with a few short examples. And we have the model generation next, which is not correct over here. There's there's error in one step in this case. Then we asked annotators to correct this model generation so that we have a correct answer and reasoning chain. Uh, Along with that, we also collect error type of what error was there in this model generation. So we came up with 4 different categories which were most common in the generations. So like factual error, or there could be missing facts, and so on. So we have these 4 types, and then we ask annotators to mark either one or more of these which are present in model generation. And finally, we also collect description in natural language, which describes what error is there in model generation, along with the step that includes this error. So in this way, we have this rich feedback data set containing a lot of diverse feedback for each example. And we give feedback throughout to ensure like high quality. And in total for 2 data sets, we have about 2,200 examples. And the data set is publicly available. I have the links towards the end in this presentation. We tried 2 methods to update or fine-tune models based on this collected feedback. So the method that we tried was a simple multitask learning baseline. So what this means is essentially we'll fine-tune the model to predict each different kind of feedback that we have conditioned on either the question or the question model generation. So the 3 terms in this case is, firstly, you want to predict the correct answer given the question. The second term is you want to identify the error given the question and the model generation. And the third is describing it in natural language given the question and model generation. So we use appropriate instruction for each of these terms. So for example, for the second term over here, you might use an instruction like predict error in the given answer. We also tried one more method, which is weighted self-consistency. So what this does is essentially use the same fine-tuning objective as before, but instead of sampling one answer, what we'll do is we'll sample multiple answer. And then for each of them, we'll identify what error is there in this answer by using the second term in this case, the P of T given Q and M. We'll just prompt the model to predict answer, predict error, and then we'll do an aggregate vote across all of them. So answers which don't have error will have a higher weight, and answers which have an error will have a lower weight, and we'll aggregate this to obtain the prediction. So those are the main set of results that we have on the 2 data sets. So for strategy QA, we found that our methods perform comparable to an in-context learning baseline, not that much better, but they do seem to help on the sports understanding data set. But more importantly, what we found was once you fine-tune the model with our feedback, the model is now better at judging the correctness of its own answer. So this last row is when you do a few shot prompting to detect errors. So if you'll have few short examples of whether the generation has errors or not, And then you find that this model is better than either the base model or simple baselines like majority. So to summarize, we have this rich human feedback data set of about 2,000 examples. We found that fine-tuning on this feedback sometimes helps with reasoning performance, but more importantly, it helps to judge correctness. And yeah, paper and data set are available. Feel free to check it out. And I could not be there to present today, but feel free to email me if you have any questions. Thank you.